All right, so I know there are 3x3 examples on this document, but we're not going to do those. I am going to show you some other stuff that we're going to do with 3x3s, but it's just not going to be solving equations using matrices. So a 2x2 system, linear system, you can solve doing substitution, elimination. You can graph and look for an intersection point. We did Cramer's rule last week, which added a fourth method. Now we're going to add a fifth method for solving a systems of linear equations by using inverse matrices, which we did last week. So one of the things that we're going to do is, first of all, we're going to take the linear equation and we're going to write it in matrix language, okay? Now, A, B, C, D, that's your coefficient matrix, A, B, C, D. Then you have a variable matrix. Notice it's X and Y because those are the variables used in this. If the variables were M and N, then the variable matrix would have M and N in it, whatever variables are being used. And then, of course, we're going to set that equal to the constant numbers. So if matrix A are the coefficients or is the coefficient matrix, X is the variable matrix, and B is the constant numbers, then you can take A times X and it will equal to B. Now, if that is the case, and we need to figure out what X and Y are, because when you solve a systems of equations, that's what you're looking for, your X and your Y value. We can solve for X by taking the inverse of A and multiplying it by the B matrix. Now, we did inverses last week. All right. It has to be in this order. It has to be in this order. If it's not in the order, you can't do matrix multiplication with it. It has to be in that order, the inverse first and the coefficient or the constant matrix last. So we have three steps. We're going to write the systems as a matrix equation, A times X equals to B. We're going to find the inverse of A, and then we're going to multiply the inverse times the B matrix, okay? So how this works, coefficient matrix, 7, 5, -6, 1. That's A. Coefficient matrix, I take all the coefficients from X and Y and I write them down. Now, I'm going to list my variables in a column, whatever they are, X, Y, M, N, A, B, doesn't matter. And I'm going to, so that's my matrix X. Then I'm going to set it equal to the constant numbers, -14 and -25. Sometimes it's a lot easier to see it when the numbers come out. And this is matrix B. Now, my goal to figure out what matrix X is to multiply the inverse of A times B. So here's my inverse times my B value or my B matrix, and that's going to equal to X and Y. The most time-consuming part is going to be finding the inverse and then doing the matrix multiplication, okay? So the first thing we're going to do when we find the inverse, you have to find the value of the determinant first, because if the value of the determinant for the inverse is 0, you have no inverse. So always do that part first. So 7 times 1 is 7, minus 5 times -6, which is -30. That gives us 37. So we can keep going. So that gives me 1/37. To find the inverse, remember these two switch places. So 1 and 7 switch places. What do I do with 5 and negative 6? Change the signs. That's exactly right. So negative 5, positive 6. And as ugly as this may turn out, that's okay. I have to distribute that scalar 1 over 37. So if you do not want to write it here, because we are going to have to write it here, 1 over 37 times 1 is 1 over 37. 1 over negative 5 is negative 5 over 37. 1 over 37 times 6. And 1 over 37 times 7. Now, none of those numbers actually reduced or divided out evenly. So as ugly as that is, that's my inverse. Now, the next thing we have to do is we actually have to take this 2 by 2, multiply it by this 2 by 1, and that produces this 2 by 1. Everybody okay with that? Now, matrix multiplication. You go across this row that has 2 elements in it, pair it with these 2 numbers. So 1 over 37 gets paired product-wise, multiplication-wise, with negative 14. We're going to add that to negative 5 over 37 times negative 25. That's going to give me the top number. I took my top row, paired them off, paired those 2 elements with these 2. We're going to do the math in the calculator in just a minute. And then I'm going to do the same thing with 6 over 37 and 7 over 37. So 6 over 37 gets paired with negative 14. Add that to 7 over 37. Pair that with negative 25. Once you let your calculator do the math, you have your answers. When you do the top number, you should get 3. When you do the bottom combo, you should get negative 7. Cell phones go away. My time. Is that what you got when you did all that ugly math? Okay, so that means these 2 equations intersect at that one point. So your answer would be 3, negative 7. All right, so for example number 2, first thing, we set up the problem. Coefficient matrix times the variable matrix equals to the constant matrix. So I'm going to take the inverse, multiply it by the constant matrix, and that will give me, so inverse times constant matrix equals to the variable matrix. So I have to find my inverse first. So to calculate the inverse, the first thing we need is the determinant of the coefficient matrix. So that's negative 60. 12 times negative 5 is negative 60 minus negative 88, which ends up being 28, To keep going with that, I have 1 over 28. I need to rearrange those numbers in that coefficient matrix. So the -5 and the 12 change places. And I change the sign on the 11 and the -8. So now I'm going to distribute 1 over 28, that scalar, into the matrix. So that's -5 over 28, -11 over 28. 8 over 28 actually reduces to 2 over 7. 8 over 28 reduces to 2 over 7. And 12 over 28 reduces to 3 over 7. If it reduces, that's less math that you have to do. Now we're ready to do our matrix multiplication. To get the first number, pair these two elements with these two elements. So -5 over 28 times -35 plus -11 over 28 times 21. That's going to give you x. Then take the bottom row, pair it off with the 35 and the 21. And that will give you the y value. You should get -2 and -1. -2 for your x coordinate and -1 for your y coordinate. Any questions so far? All right, so I'm going to pause and I'm going to give you time to make it all the way through number 3. While you're working it out, I'll write down the steps and then you can check. All right, that's what I got, -8 and 4. Any questions about any part of that? Because I can walk you through it. Anybody? All right, so examples 4, 5, and 6, since they are 3 by 3s, we do not have to do them. The next page in your packet should say augmented matrices. Now, with the augmented matrices, I'm going to show you how to solve 3 by 3 systems. Because to me, since we did not learn how to do the 3 by 3 inverse, which is extremely time consuming, this is an option for using matrices to solve 3 by 3 systems. Okay. So let me catch up with y'all. All right. So an augmented matrix of a system of linear equations uses coefficients and constants of the equation written in standard form. So notice each one of these equations is written XYZ constant all the way down. So the augmented matrix, basically you write all the numbers in order, just drop the variables. So that would be 2, -7, 1. Now, I always put a line where my equals is. You do not have to put a line where the equals is. I just like to separate It's just a personal thing. My constant are my constants from my coefficients, okay? So I like to know where the equal sign originally is in the problem. Then I have 1, 5, -8, and 81. And then my last row is -1, 4, 3, and -18. Now, when you are writing an augmented matrix, double check and make sure you didn't lose a negative somewhere, because it is extremely easy to do at the very beginning, mess up and leave off a negative off a number. Very, very easy to do. And then the rest of your problem, you've just wasted your time because one number is wrong. The rest of it doesn't work out. Does that make sense? So always double check. And I just go down, it's positive, positive, negative, negative, positive, positive. You know, I check it however you want, but make sure your signs are in the right places. Now, the row echelon that we're going to kind of talk about today, or some people refer to it as the triangular form, is when the last equation contains just one variable, typically z, and each equation above that one gains another variable, okay? So if you notice, the bottom equation is a z. When you go up one, you've got yz. And then if you go up to the top, you have x, y, and z. So you start with z and you backtrack to yz. You picked up the variable y. Then you pick up x on the top row. The reason they call it a triangle or the triangle form is that there are values missing. And those values just so happen to form a triangle in that bottom left-hand corner. Does that make sense? That's why they call it the triangular form. It's row echelon, regardless of what it is. Now, to take this and put it into augmented matrices form, I've got 1, -2, 5. You do not have to put this bar. I just do it to separate my coefficients and my constants. 0, 1, -6. I don't have an x, so I got to put a filler. And then I have 0, 0, 1, -3. Now it's really easy to see the triangle when the zeros are in the matrix, because that bottom corner is a 0. But what's special about the main diagonal? What do you notice about the main diagonal in this problem? They're all ones. That's exactly right. Okay, that is ideal scenario. You want 1x, 1y, 1z as you go down that diagonal. Okay, so that is ideal scenario. So what we're going to talk about is how we can use this row echelon and row operations to actually take a system and rewrite it in this format so that we can solve it. Okay, so let me back up. Back substitution. If I know what z is, can I not take -3, plug it in here, and figure out what y is? Then once I know what y is, can I take z and y and plug it in up here to get x? That's what they call back substitution. Start with the bottom row and back your way up to all the variables. Does that make sense? So that's what they call back substitution. But we're going to have to do a mixture of these elementary row operations to produce this, because not all systems are going to be set up like this for you. You're going to have to manipulate and create. Okay? Now, one thing you can do is you can take any 2 rows and switch them. If you don't like the numbers in row 1 and you want to switch that whole row with row 2, switch it. Nothing says that you can't. You can multiply a row by any non-zero constant number. Non-zero, can't multiply by zero because that wipes out your whole row. Any row can be multiplied by any number that you want. Positive, negative, decimal, fraction, not zero. And then we're going to add a multiple of one row to another, okay? So we can do lots of things. What you do not divide. You can add, subtract, you can multiply, but you do not divide. And I'll show you how to. It'd be real easy if we could divide, but I'll show you the proper way to write that kind of division thought in multiplication format. All right, so what we're going to do is we are going to write the system in augmented matrices, which we've done twice. Transform the matrix to row echelon. That means main diagonal is a 1, bottom left corner, all zeros, okay? Use row echelon to rewrite the system, put X, Y, and Z back into the problem, and then do back substitution to solve, okay? So notice that they give us a lot of space. So the first thing it tells us to do is write the matrix in row echelon form. So 1, 2, -9. Put the bar, don't put the bar, totally up to you. 0, 1, and 4. This equation does not have an X. You have to put in fillers when you don't have something. Bottom row has X, Y, Z, so 1, -1, 3, 25. So 1, 2, negative, double check all my numbers, make sure I've got my zeros if I need one. So if you have an equation that's missing an X or Y or Z, fill in the zero, fill that place in with a 0, okay? So now, according to what was here, I can transform the matrix by using any of these operations. If I want to switch 2 rows, I can do that. If I want to multiply one row by something to change it, I can do that. If I want to add 2 rows together, I can do that. So what I want to do, and this is what I always do, this gives me a pattern to follow, a method to the madness, so to speak, okay? The first thing that I always do is I make sure that this number is a 1. Good to go. I am happy with row 1. That entire row is perfect, okay, because it's got that 1 in the top corner. Next thing I'm going to do is I'm going to look here. I want a 0 here. Got it, okay? If I have a 0 here, the next thing I want is a 1. So second row is good. The problem is when I come down here, what should that number be? It should be a 0. It's not. But I can make it a 0, okay? So when we do row operations, you have row 1, row 2, row 3. So what I'm going to do is I am going to take row 1 and subtract row 3 from it. I can add 2 rows together. I can subtract them. I can multiply them by whatever I want. Okay, so over here in my workspace, I'm going to take 1, 2, -9, -59, 1, -1, 3, and 25. I'm going to draw my line and I'm going to subtract every single one of those numbers in the row, in the columns. So 1 minus 1 is 0. 2 minus -1 is 3. Minus negative becomes plus positive. -9 minus 3 is -12. Negative 59 minus 25. Negative 84. Okay. Now, notice that I put my row operations next to row 3. So what I'm going to do is I'm going to rewrite this whole matrix, but I'm going to take this line out and put those numbers in its place. Okay. You have to create the scenario. Now, when you always identify your row operations next to the row that you are replacing. Okay. I didn't put R1 minus R3 up here because I wasn't replacing row 1. I need to fix row 3. Okay. Now, I got my 0. Well, my next problem, that needs to be a 0. Okay. So work smart, not hard. I'm going to actually pair these two equations together. Okay. Because if I multiply either one of these zeros by anything, will it change them? And then if I go to add or subtract them, would they still stay 0? You don't want to lose a 0. Once you get your zeros in place, keep those zeros. So I need to figure out what I can do to either one of these rows to get a 0 right here. I'm sorry? Okay. Well, could I do this? Negative 3 times row 2 and then just add it to row 3? Or subtract, right? So just some options. A negative 3 plus a positive 3 would give you 0. If you don't want to do that, you always have the option multiply this row by 3 and subtract that row from it because 3 minus 3 gives you 0. Since you suggested that, we'll stick with that. Okay. Isn't that what you suggested? Okay. So 0. 3 times 0 stays 0, which is great. Then I get 3, 12, 36. I am going to subtract the bottom row as is. So 0, 3, negative 12, and negative 84. So 0 minus 0 stays 0. You do not want to lose that 0. 3 minus 3 becomes 0. 12 minus negative 12 becomes 24. 12 minus negative 12 becomes 24. And 36 minus negative 84 becomes 120. Y'all agree? Now, we did all that so we could replace row 3 and get our zeros in the spots, right? Okay. The problem is, instead of me writing it down again and then having to change it a third time, this is my new row 3. Do y'all agree? Now, before I put it back over here, I am actually going to do one more row operation. I am going to multiply by 1 over 24. I can't divide by 24, but basically, if you multiply by 1 over 24, technically you're dividing. But in matrix language, you don't divide. Does that make sense? So we have to show it as a multiplication problem. That changes this to 0, 0, 1, and 5. My bottom row is now exactly the way I want it with a 0, 0, 1, 5. So I'm going to come over here. It is very easy as you are trying to go back and rewrite all of these over and over and over to miss a sign. So be very careful. Now, I have my diagonal of ones. I have my bottom corner of zeros. So now it's time to put the variables back. This is x plus 2x, or 2y, sorry, putting the wrong variables in, minus 9z equals to negative 59. My second equation is y plus 4z equals to 12 because there's a 0 where x should be. And then the last row says that z is 5. Now, when you solve a two-variable system, you get xy. We're solving a three-variable system. This is called an ordered triple because there are three variables. This is an ordered pair, and that's for a 2x2 system. This is an ordered triple because you have three equations, three variables. So we're going to work backwards. I know z is 5. I'm going to take that, plug it in here. That gives me y plus 20. 4 times 5 is 20 equals to 12. So my y value is going to be negative 8. See how I'm working backwards in my ordered pair? I've told y'all before, the car cannot always go forward. Sometimes you got to put it in reverse and go backwards. Now, I can take these two numbers, plug it into the top equation, and get x. So x minus 16. 2 times negative 8 is negative 16. Minus 45 gives me negative 59. When it's all said and done, what is my value for x? Anybody? That would be 2. That is correct. So that is the ordered triple that solves this system. If you were to plug these three numbers into the original problem, the first equation would equal to negative 59, the second one would equal to 12, and the last one would equal to 25. So therefore, you have your answer. Okay? Everybody okay with that? All right, we're going to do 2 more, and then I'm going to get you started on some homework. So notice in this one, we have all 3 x's, all 3 y's, all 3 z's. So we don't get lucky. We don't get started with any of the zeros. So the first thing I'm going to do, write down the row echelon form. So that's 1, negative 1, 4, and 6. 1, 1, negative 2, negative 14. 1, 2, 5, and 6. All right, is my first row set? Do I have in that 1 in the first spot? All right, so now what I'm going to do is I'm going to go after that 0 first. I just have a method to the madness, and I go after, I get a whole column done, then I move to the next column. So I'm going to get this 0 first, then I'm going to go after this one. Any ideas of what I could do to get that 0? From which row? The third row? So you want to say row 3 minus row 2? Could I have said row 1 minus row 2? Could I have said 1 minus 2? Could I have said 2 minus 1? Could I say 2 minus 3? There's all kinds of ways that I could get that 0, okay? So 3 minus 2 it is. That was the first suggestion. So make sure you write down row 3 first. We're going to subtract row 2 from it. One minus 1 gives me a 0. That's what I was going for. 2 minus 1 gives me a 1. Well, look at that. I got lucky. Because in that second row, don't we want a 1 and a 0 and a 1? So we got lucky. Then 5 minus negative 2 is 7. And 6 minus negative 14 is 20. Be very careful. Do not accidentally add down and get 3 or add down. You're not adding, you are subtracting. That's the row operation you opted for. All right, so row 1 stays. Row 2 comes out and gets replaced with 0, 1, 7, 20. Row 3 stays. The only thing we did is we used row 3 to help us create what we needed in row 2. All right. Now, sometimes you get lucky, sometimes you don't. So now I'm going to go after this 0. What can I do to get that 0? Could I say row 1 minus row 3? Could I do row 3 minus row 1? Would I want to pair this with row 2 at all? No, because it's going to take it's not going to give me a 0. So which one do you want to do? 1 minus 3 or 3 minus 1? It really doesn't matter. The only difference is the numbers will be the same, but all the signs will be opposite. It depends which one you want to do. 1 minus 3 or 3 minus 1? I don't care. Pick. All right, we'll do 1 minus 3. So 1 minus 1, positive 4, 6. We're going to subtract 1, 2, 5, and 6. One minus 1 gives me the 0 I was going after. 1 minus 2 is negative 3. 4 minus 5 is negative 1. And 6 minus 6 is 0. Everybody okay so far? Now, this is not the only way that you can work this. You may see different combinations that you want to do. The main goal is to get these zeros in place and get those ones in place. So 1, negative 1, 4, 6. Top row is perfect. Middle row, we fixed it, so it's awesome. So now I'm going to go after this 0. I just go after my zeros in order. What do you think I could do to make this become a 0? Now, if you don't want to lose these 2 zeros, work with just those 2 rows. If you try to pair row 3 with row 1, you're going to lose this 0. That's why I do that column of zeros first. That way, when I get ready to do this 0, I don't have a choice but to pair 2 and 3, row 2 with row 3 in some way, shape, or form. Make me a suggestion. Okay, so 3 times row 2 and add it to row 3. Is that what you were saying? Is that what you said? Combine it with that? All right. So 0, 3, 21, 60. I multiplied row 2, every number by 3. We're adding this time 0, -3, -1, and 0. So I get 0, 0, 20, and 60. Once I get my 2 zeros, which is what I was setting out to do, I'm going to come over here and I'm going to say 1 over 20 times row 3, because that way I can reduce all those numbers by 20 and I can get my 1. I don't care what this number is. You're going to put 1 over that number and make it a 1. Okay? So now we are at 0, not 0, sorry. Top row is perfect. Now remember, 20 times 1 over 20 gives me 1. That's where this one came from. 60 times 1 over 20. 20 goes into 6 3 times, so that's where the 3 comes from. So now I know x minus y plus 4z equals to 6. I know y plus 7z equals to 20. And I know that z is flat out 3. So now you are ready to back substitute. Take 3, plug it in. I multiplied everything by 1 over 20. 60 over 1 over, or 60 times 1 over 20 becomes 3. So this would be y plus 21. 7 times 3 is 21 equals to 20. So y is -1. And then I'm going to come into the top equation and plug those two numbers in for y and z and figure out what x is. So x plus 1, -1 is plus 1, plus 12 equals to 6. So x ends up being -7. Everybody okay with that one? All right. Last one I wanted to do is number 3. So the first problem I see, I do not have a 1. I have a couple of options. I could switch row 1 and row 2. Y'all agree? Because that would put a +1 up here. If you simply want to switch a row, if you wanted to switch out row 1 and row 2, you would say, I'm going to switch row 2 with row 1. Double arrow means you're just switching rows. You're not multiplying, you're not adding, You're just switching them. Okay, so you could do that. You could also multiply the top row by 1/4, which in essence, mentally, what are you doing? You're dividing every number by 4, but you can't say when you're talking about matrices, you can't divide by a number. So you have to show it as multiplication. So which one do you want to do? I've given you two options. Do you simply want to switch the rows, or do you want to multiply the top row by 1/4? Somebody pick. Switch. All right. So we are going to take row 2 and switch it out with row 1. So that gives me 1, 2, 1, and 11 in my top row. 4, -4, 8, 12 as my second row, and we did not touch row 3. I'm going to go after this 0 first, now that I got the first row the way I want it. Any thoughts? How am I going to get that 0? I'm sorry? Row 1 plus row 3. If you do 1 and 3, you cannot replace row 2 with it. So do you want to get this 0 first and then go back and get this one? In order to replace a row, you have to use the row in the calculation. Does that make sense? So I can't add 1 and 3 and then put it in row 2. If I'm going to change row 2, I have to use that as part of the calculation. Now, if you want to say row 1 plus row 3 and get this 0 first, there is absolutely nothing wrong with that. What you need to do is you need to get these two zeros first and foremost. Work down the column. Get the first column the way it should be. Okay? So if you want to add row 1 and row 3, that would be 1, -2, 1, and 11, -1, 1, -3, -1. Draw your line and add those numbers together. That gives me 0, -1, -2, and 10. Now, I cannot put that in row 2's spot because we didn't use row 2 to calculate it. But I am going to put it down here in the bottom row. Now, before I do anything else, I need this 0. So it doesn't matter if you get it here or if you get it here. You got to get it somehow. I give you a hint. These two rows have to be used. What can I do to get my 0? Okay, so say that again. Okay, so 1/4 row 2 minus row 1. Okay, so 1/4. Basically, you're dividing everything by 4. Do y'all agree? So that would be 1, -1, 2, and 3. We don't show it as division. We show it as multiplying by 1/4. We are going to subtract 1, -2, 1, and 11 from that. 1 minus 1 gives me 0. 1 minus -2 gives me +1. 2 minus 1 gives me 1. And 3 minus 11 gives me negative 8. Do y'all agree with those numbers? Y'all double check me. Y'all are good? What? Negative 1 minus negative 2, positive 1. Yes, ma'am. And see, subtraction is really hard. I prefer to add. That's just me. Subtraction is harder. So if I can figure out a way to be able to add these numbers, if you want to add them, do you know what you can do? You can go plus, minus, plus, minus, minus, add straight down. 0, 1, 1, negative 8. If you set it up as a subtraction, you can distribute that subtraction all the way across the bottom if you would rather add. Totally up to you. So now my top row is still 1, negative 2, 1, and 11. My new second row is 0, 1, 1, negative 8. I actually got 2 for the price of 1. Not only did I get my 0, but I got the 1 I needed in that bottom row. We got lucky when we did it that way. Now, when you go after this 0, pair these two lines only. I can just simply add row 2 and row 3 together because 1 and negative 1 will produce that 0 right there. So 0, 1, 1, negative 8, 0, negative 1, negative 2, and 10. I'm going to add those two rows together. Gives me 0, 0, negative 1, and positive 2. Now, that is going to be my new third row. What should I do to it before I actually put it back into the matrix? So negative 1, row 3. So when it's all said and done, top row, middle row is done. Bottom row would become 1 and negative 2. The only thing I know right now is that z is negative 2. So I have x minus 2y plus z equals to 11. Y plus z equals to negative 8. And z equals to negative 2. We're going to back up. We're going to plug negative 2 here into this second equation. So y minus 2 equals to negative 8. So y gives me negative 6. And then I'm going to go into the top equation. That would be x plus 12. Negative 2 times negative 6 is positive 12. Minus 2 equals to 11. So x ends up being positive 1 when it's all said and done. Positive 1, negative 1. Positive 1. And that would be my ordered triple. Make sense? Now, there are 12 of you in here. Actually, there are 11 of you in here. Nope, I was right the first time, 12. So Y'all are all going to approach this differently. And that's okay, as long as your row operations are valid. And you get that, go for the first column first. I'm telling you, get that first column set. Get your 1, your 0, your 0. Then move to the second column. Make sure this is 1. Make sure that is a 0. Okay? Best thing I can tell you to do. Or you'll go around in circles and it will last forever. All right. So, any questions?